Would you honestly let an AI agent autonomously patch a production vulnerability, alter your Terraform state, or push a fix directly to a live Kubernetes cluster without any manual review from you? If you ask any experienced engineer this question, the answer, based on the data, is an immediate resounding no. Hell no, actually. There is just this massive, gaping chasm between a really slick AI demo running in a perfectly controlled sandbox environment and actually giving a non-deterministic large language model right access to your mission-critical revenue-generating production systems. Think about it this way. If a generative AI writes a marketing blog post and it's, say, 70% correct, that's a huge win. You just manually edit the remaining 30%. But infrastructure code is binary. It either works or it brings the whole company offline. If a Kubernetes YAML file or a Terraform configuration is only 70% correct, your pods are going to crash into a back-off loop. Your network policies might black hole all incoming traffic, or worse, you might accidentally expose an internal, highly sensitive database to the public internet.
To really make sense of where we are going with AI, we have to take a step back and look at where we've been. If you trace this timeline, you're looking at the historical evolution of operational scale. Back in the 1990s, a system administrator was manually babysitting maybe 10 physical bare metal servers in a freezing cold server room. Then the 2000s hit, virtualization came along, and suddenly that exact same admin could manage 100 virtual machines. Move into the 2010s, and the cloud, combined with infrastructure as code, meant one single engineer was now deploying thousands of virtual resources via scripts. Then, of course, came the container revolution and Kubernetes in the 2020s. And here's the fascinating part. Every single time one of these massive, revolutionary automation technologies arrived on the scene, people panicked. They swore it was the end of IT operations jobs. But those jobs didn't disappear, did they? The tools simply expanded the scope and the blast radius of what one single human being could manage. Automation historically has never eliminated engineering responsibilities. It just shifts them up to a higher level of abstraction. AI isn't the end of DevOps. It is simply the very next layer in this exact same historical progression.
But we really need to break down the hype versus the reality here, because when you look closely, a very clear picture emerges. The AI marketing promise is almost always framed as this magical, 100% autonomous, self-healing infrastructure. It's the utopian idea that the system just magically fixes itself while you play ping pong. But the actual production reality as we look toward 2026 is distinctly different. The reality is, AI investigates and identifies, while the human validates and executes. We are not outsourcing the final implementation to a bot. We are outsourcing the initial painful triage. When a massive incident occurs, you should treat the AI like your ultimate, incredibly fast junior analyst. It rapidly pulls together all the disparate pieces of logging data, metrics, and traces so that you, the seasoned professional with the actual pager, can use your deep, hard-earned domain expertise to validate the AI's hypothesis and safely execute the actual fix.
Let's actually walk through what this translates to any realistic daily engineering workflow. Notice how heavily this leans on a read-only approach. Step 1, the PagerDuty alert fires at 3 a.m. Step 2, before you've even managed to open your laptop and rub the sleep out of your eyes, the AI agent has already aggregated the application logs, queried the Prometheus metrics, and checked GitHub for any recent configuration changes or merged pull requests. Step 3, the agent posts a neat little summary directly into your Slack incident channel, suggesting the most probable root cause based entirely on that massive pile of aggregated context. And finally, Step 4, the human engineer reviews that summary, checks the logic, and validates the fix. Because this workflow is strictly read-only, the risk to your production environment is incredibly low. If the AI completely hallucinates or just guesses wrong, whatever, you've lost maybe 2 minutes reading a bad Slack message. But if it guesses right, it just saved you 30 to 60 minutes of frantic, adrenaline-fueled log searching across 6 different observability tools. It doesn't fix the broken pipe for you, but it points a really bright flashlight directly at the leak.
Now, beyond just incident response, there are very specific isolated pockets where AI is genuinely shining right now, today. Notice these specific areas on the board. They all represent high-toil, highly repetitive work. We're talking about scaffolding out the boilerplate YAML for a brand new GitHub Actions CI/CD pipeline from scratch, or troubleshooting that one completely invisible, maddening indentation error in a 2,000-line Kubernetes deployment manifest. It is amazing at summarizing thousands of lines of chaotic application error logs into a single readable paragraph. It's great at generating the initial baseline modules for a new Terraform state, or even looking at a bloated Docker file and suggesting optimizations to reduce your container image size. These are mundane tasks where you, as the engineer, can easily and safely verify the output before actually applying it.
AI is incredibly effective at spotting patterns and generating standard syntax, which is fantastic because it frees teams up from the mundane typing so they can actually step back and focus on the overarching system architecture.
But, and this is a massive but, here is where we have to shift our focus to the inherent, unavoidable dangers. The absolutely crucial concept to understand is non-deterministic output. Look, large language models are fundamentally just advanced probability engines predicting the next sequence of tokens. They are unpredictable by their very nature. You can give an LLM the exact same prompt word for word twice in a row and get two completely different infrastructure configurations back. One of them might be a perfectly valid, beautifully written Terraform module. The other might contain deprecated AWS API versions, entirely fabricated parameters, or really subtle, nasty security flaws. You literally cannot treat an AI like a traditional deterministic Python script where input A always equals output B. When you are dealing with critical, highly sensitive cloud environments, this non-deterministic nature means you must treat every single piece of AI output with extreme skepticism and rigorous automated testing. And it's exactly that unpredictability that leads directly to the massive dangers of fully autonomous agents. The data highlights real-world examples of this going incredibly wrong. We've seen instances where an AI agent, tasked with simply resolving a minor permission issue, gets frustrated and simply hallucinates an overly permissive IAM policy. It'll basically grant wildcard administrative access to the entire public internet just to make a red error message turn green. Autonomous agents lack true holistic environment awareness. They do not inherently understand your specific business constraints, your compliance requirements, or the sheer catastrophic financial risk of accidentally dropping a primary billing database. Highlights terrifying instances where agents explicitly ignore instructions to safely use GitOps and make a pull request. Instead, they decide it's simply faster to try and apply a raw manifest directly to a live production cluster, completely bypassing every single safety check, unit test, and peer review process your team has built. A big technical reason for these spectacular failures actually comes down to how these models process data, which is perfectly illustrated by the usability chart right here. AI models have a hard limit to how much information they can actually hold in their working memory at any given time. This is what we call their context window. But here's the catch. Just because an AI model technically supports a massive 200,000 token window, that does not mean it uses all that space well. Studies and practical engineering experience show that when an AI gets overwhelmed with massive amounts of system architecture data, thousands of lines of logs, and giant code bases, its performance degrades really, really sharply. Once that context window gets past roughly 40% capacity, the model just starts forgetting initial rules, it drops your security guardrails, and it starts heavily hallucinating solutions. You simply cannot dump your entire enterprise network architecture into a prompt box and expect flawless genius execution. It just doesn't work that way. So the most crucial point to take away from all this is captured brilliantly in this quote. AI is replacing tasks, not ownership. You can entirely automate the generation of a complex Terraform module, sure, but you cannot automate operational accountability. When a production cluster goes down hard in the middle of a busy Tuesday because of a bad configuration, the company cannot fire the AI. The executives are going to look directly at the senior engineer who blindly approved that pull request and push the deploy button. The engineering team is still the one taking the risk and remaining fully responsible for the architecture. The tasks themselves become significantly faster, yes, but the ownership and the heavy operational accountability remain firmly, solidly on human shoulders. If you're enjoying this deep dive, consider liking the video and subscribing to DevOps Corner for more DevOps and infrastructure content. All right, let's move back to the systems themselves. Notice the core principle highlighted right here. System context is everything. Good documentation powers good AI. Look, the absolute biggest misconception in the industry right now is that an AI will magically understand your bespoke, duct-taped 10-year-old legacy infrastructure just by glancing at a few error logs. It won't. If your environment is completely undocumented, if your naming standards are totally inconsistent, and if everything relies on tribal knowledge that is exclusively locked inside the head of a senior engineer named Dave who's been there for a decade, well, AI is going to be entirely useless to you. AI requires massive amounts of structural, organized context to function accurately. This breakdown here shows exactly what that means in practice. What an AI assistant needs is exactly what modern DevOps teams must rigorously build. An AI needs to know the strict naming conventions, the specific corporate security policies, which AWS regions are legally allowed for deployment, and the strict organizational guardrails. This means the day-to-day job of a cloud engineer is shifting heavily toward creating incredibly clean, highly standardized platforms.
Teams have to build crystal clear architecture diagrams, maintain pristine, perfectly organized GitOps repositories, and write highly detailed machine-readable runbooks. The unglamorous work done to organize, standardize, and document your systems is the direct, mandatory investment required to make AI tools actually effective. You aren't just writing docs for the new hires anymore. You are building the exact context store that your AI agents learn from.
And how does the AI actually securely access all that beautiful context you just built? That is exactly where the Model Context Protocol, or MCP, comes into play. Right now, a lot of engineers are just manually copying massive blocks of JSON error logs and pasting them into a web chat window. It's clunky and it's slow. MCP changes that entirely. It provides standardized, secure APIs that allow your AI assistant to directly, but safely, read your live Kubernetes cluster states, query your internal GitHub repositories, and inspect your cloud environments in real time. Instead of you having to explain what the infrastructure currently looks like, MCP allows the AI to pull the current live breathing state of your distributed systems automatically. This makes its troubleshooting suggestions infinitely more accurate and deeply context-aware. It's a total game changer for incident response.
But as we integrate all of these amazing tools, we must remember this fundamental law of engineering. Every task automation shifts the failure mode upstream. Think about it. When we fully automated server provisioning with Terraform, outages stopped being about some guy accidentally clicking the wrong radio button in the AWS console, and they started being about fundamentally bad architectural logic written directly into the code. Now, as AI agents start automating the code writing itself, the failures will stop being about basic YAML syntax errors or a missing bracket. Instead, the failures will shift further upstream to massive, incredibly complex architectural design flaws or engineers blindly approving CI/CD pipelines they don't actually understand. The system problems don't magically go away, they just become vastly more complex, wider in scope, and much harder to untangle.
And because those failure modes are becoming so much more complex, the core engineering fundamentals highlighted right here are actually more important than ever before. If you don't understand Linux internals, advanced networking protocols like BGP, security compliance, and underlying Kubernetes architecture at a really deep level, you simply cannot validate whether the AI's output is brilliant or disastrous. You cannot spot a subtle, nasty security flaw in an AI-generated Terraform plan if you don't know what secure Terraform actually looks like in the first place. The foundational knowledge of how systems physically communicate, how networks route traffic, and how permissions are mathematically granted remains absolutely critical. Added to these timeless fundamentals is the new core skill of prompt and context engineering, knowing exactly how to constrain and guide the AI to give you safe, truly production-ready outputs. And honestly, there is an incredible, almost poetic irony to all of this, perfectly captured by this data point. 66% of organizations are running their generative AI workloads directly on Kubernetes. Think about that for a second. The very AI tools that tech media fearmongers say will replace infrastructure engineers are completely reliant on the massive, complex distributed infrastructure that DevOps engineers build, manage, and scale. AI data centers are receiving trillions of dollars in investment globally, and all of those models, all of those LLMs, are running inside containers on platforms orchestrated by human engineers. If the AI industry continues to explode in growth, the physical and virtual infrastructure underneath it must grow at the exact same rate, totally securing the future for the people who know how to operate those underlying systems.
So, mapping out the next 3 to 5 years, the evolution of the role is crystal clear. We have to completely move away from manual clicking in cloud consoles and writing isolated, fragile bash scripts. Instead, the focus is shifting to building robust internal developer platforms. These are standardized, highly documented, golden path environments where both human developers and AI agents can safely operate without breaking things. The role is transitioning from being a tool operator to supervising an AI factory. You are setting the guardrails and defining the platform, while the AI handles the repetitive toil. This shift means human engineers can finally focus their energy on the absolute hardest problems in tech: system reliability, extreme resilience, and aligning technology architecture with deep business needs. Which leaves us with this final, genuinely provocative question to think about. Are you just operating tools, or are you actively engineering the autonomous platforms of the future? Look, if your entire professional value proposition is just memorizing CLI syntax and manually executing deployments day in and day out, the coming years are going to be highly disruptive for you.
But if you choose to focus on deep system fundamentals, scalable architecture, rigorous documentation, and utilizing AI to massively scale your own human capabilities, you are going to be more valuable to the industry than ever before. The DevOps role isn't disappearing at all, it is evolving, and the adaptable engineers who embrace this massive shift will be the exact ones leading the industry into 2026 and beyond. If you found this helpful, make sure to like the video and subscribe to DevOps Corner for more deep dives like this.